Introduction to differentiation. Draw the graph of y equals 2x plus 3 for x values greater than -2 but less than 3. So what we're going to do is take our equation or our function, which is y equals 2x plus 3, and we're going to substitute x values in place of this x, and we're going to substitute x values from -2 up as far as 3. So starting with x equals -2, our equation is y equals 2x plus 3. So we're going to swap that x for -2 with brackets around it. So we get y equals 2 multiplied by -2 plus 3. 2 multiplied by -2 is -4, and -4 plus 3 is -1. So when x is -2, y is -1. So we're going to plot the point -2, -1 on our graph. So we go to -2 on the x-axis, which is here. We go to -1 on the y-axis, which is here, and plot our point. And there we have the point -2, -1. So we want x values from -2 to 3, so the next x value is going to be -1. So we do the same thing. So we swap that x for -1 with brackets around it. 2 times -1 is -2, and -2 plus 3 is 1. So we have y is equal to 1. So now we're going to plot the point -1, 1. So there's our point -1, 1. So it lines up with -1 on the x-axis and +1 on the y-axis. So there's our point -1, 1. So now we're doing the same for x is equal to 0. And we're going to do the same for x is equal to 1, x is equal to 2, and x is equal to 3. So we get y is equal to 2 multiplied by 0 plus 3. And 2 times 0 will cancel. Anything times 0 just cancels. And we get y is equal to 3. So our next coordinate is 0, 3. So here we have the point 0, 3. So it lines up with 0 on the x-axis and 3 on the y-axis. Now we're going to do the same for x is equal to 1, x is equal to 2, and x is equal to 3. So when x is equal to 1, we swap this x for brackets with 1 inside it. 2 times 1 is 2, and 2 plus 3 is 5. So our next coordinate is 1, 5. We'll plot that in a minute. Now we're going to substitute 2 into our equation. So we have y equals 2 multiplied by 2 plus 3. So we swap that x for 2 with brackets around it. 2 times 2 is 4, 4 plus 3 is 7. So our next point is 2, 7. And now we're going to do the same for x is equal to 3. So we have y is equal to 2x plus 3. Swap the x for 3 with brackets around it. 2 times 3 is 6. And 6 plus 3 is 9. So y is equal to 9. So our third coordinate there is 3, 9. So now we're going to plot these 3 points on the same graph. So starting with 1, 5. So we go to 1 on the x-axis, 5 on the y-axis. So 1 on the x-axis, 5 on the y-axis. And plot our point. Next we go to 2 on the x-axis, 7 on the y-axis. So 2 on the x-axis, 7 on the y-axis. So we plot our point. And then 3 on the x-axis, 9 on the y-axis. So 3 on the x-axis, 9 on the y-axis. And we plot our point. Now we have plotted all our points, and we notice that they form a straight line, and that makes sense because we have an x in our equation. If we had an x squared, we would have a u-shaped graph or an n-shaped graph. But if there is just an x in our equation, then we know we have a straight line. So here we have the graph of y equals 2x plus 3. So again, here we have our graph of y equals 2x plus 3, or f of x equals 2x plus 3, which is the same thing. And now we are interested in the limit of f of x as x approaches 2. So this means as x gets closer and closer to 2. So when x is 1 or 1.0, 1.0, y, which stands for f of x, is 5. And we worked that out in the previous slide. So when we substitute 1 into our equation, so instead of having 2x plus 3, we would have 2 multiplied by 1 plus 3, which would give us 2 plus 3, which is 5. So at 1 on the x-axis, we go up to 5 on the y-axis, and we can see that that point does lie on our line. So we're interested in the limit of f of x as x approaches 2, so as x gets closer and closer and closer to 2. So 1 you might think is quite close to 2, but we can get much closer than that. 1.5 is a lot closer to 2 than 1 is. And if you were to substitute 1.5 into the equation, we would end up getting 6 as our y value. So at 1.5, if we were to go to our graph, we would end up at 6 on our y-axis. 1.5 is quite close to 2, but 1.8 is even closer. And if you were to substitute 1.8 into the equation, we would get a y value of 6.6. But 1.9 is closer again to 2. And if you were to substitute 1.9 into your equation, you get a y value of 6.8. 1.9 is very close to 2, but 1.95 is closer again. And if you were to substitute 1.95 into your equation, you would get a y value of 6.9. And we could continue on and on and on, getting closer and closer and closer to an x value of 2. So for example, 1.999 is very, very, very close to 2. And if you substitute this into your equation, you will get a y value of 6.998. So look at what's happening as our x values get closer and closer and closer to 2. Our y value gets closer and closer and closer to 7. Now we know that if we substitute 2 into our equation, we have 2 times 2, which is 4, and 4 plus 3 is 7. So the limit of our function as x approaches 2, as x gets closer and closer to 2, is 7. So as our x values get closer and closer and closer and closer to 2, our y values get closer and closer and closer and closer and closer to 7. And if you were to go above 2, so for example, 2.001, which is just very, very, very slightly above 2, your y value will be 7.002, which is just very, very, very slightly above 7. And if you were to substitute an x value of 2.005, which is a little bit further away from 2, we would get a y value of 7.01, which again is a little bit further away from 7. And the further we got away from 2, if we got up as far as 3, if we substitute 3 into our equation, 2 times 3 is 6, 6 plus 3 is 9. So we're getting further and further away from 7. So we can see that the closer we get to 2, if we're substituting into our equation, the closer our answer gets to 7, the closer our y value gets to 7. So we can say, as x approaches 2, so as our x values get closer to 2, either from the left or from the right, our y value gets closer and closer to 7. So f of x approaches 7. It gets closer and closer to 7. So we say the limit of the function as x approaches 2 is equal to 7. The function f of x equals 2x minus 8 is defined for all x values elements of the real number set. So XER stands for x values elements of the real number set. So x values that are a part of the real number set. And reminder that real numbers are all numbers on the number line. So for example, positive numbers, negative numbers, fractions, decimals, whole numbers. By drawing a graph of the function for values of x close to 5, find the limit of f of x as x approaches 5. So as x gets closer and closer to 5. So a graph of f of x in the domain x values greater or equal to 4 but less than or equal to 6. So basically x values from 4 to 6 is shown. So here's our x-axis and here's our y-axis. So if we substitute 4 into our equation or our function, we end up with 2 multiplied by 4, which is 8, and 8 minus 8 is 0. So we have the point 4, 0. If we substitute 5 into our equation, we end up with 2 multiplied by 5, which is 10, and 10 minus 8 is 2. So we end up with the point 5, 2. And if we substitute 6 into our equation or a function, we end up with 2 multiplied by 6, which is 12, and 12 take away 8, which is 4. So we have the point 6, 4. So right here. So from the graph, we can see that as x approaches 5, so as x gets closer to 5, f of x, which is y, approaches 2. So we can see that the closer we are to 5 on the x-axis, when we touch our graph, the closer we are to 2 on the y-axis, or the f of x-axis. So also, it is clear that the limit of the function as x approaches 5 is equal to f of 5, which is equal to 2. So the closer we get to 5 on our x-axis, the closer we get to 2 on our y-axis. So for example, if you had an x value of 4.99999, we can see that that is very, very, very close to 2. It would be about 1.999. And if we had an x value of just above 5, let's say 5.01, you would have a y value of just over 2, maybe 2.01. F of x equals x squared minus 25 divided by x minus 5, where x is an element of the real number set and x is not equal to 5. Part 1. Explain why f of x is not defined for x is equal to 5. So if we were to substitute 5 in place of that x and in place of that x, we would end up with 5 minus 5 in our denominator. So we'd have 5 minus 5. And 5 minus 5 is 0. And we cannot divide by 0. It is not possible to divide by 0. So if you ever end up with a function in which you have to divide by 0, we say that the function is not defined. So subbing in 5 in place of each x, instead of x squared minus 25, we have 5 squared minus 25. And instead of x minus 5, we have 5 minus 5. 5 squared is 25. So we have 25 minus 25, which is 0, and 5 minus 5, which is also 0. So we end up with 0 over 0, which is not defined. We cannot divide by 0. So what would this look like on a graph? Well, if you look closely at your red line, which is the graph of x squared minus 25 over x minus 5, we see that at the point 5, there is a circle, an empty circle in our graph. And that is because our function is not defined at the point 5. So basically, if you substitute 5 into your function, you would not get an answer. So what you end up with is like a hole in your graph, or an empty circle. Part 2. Find the limit of f of x as x approaches 5. So since we worked out in part 1 that if x is equal to 5, we cannot define this function cannot be defined. What we're going to do is rewrite this function. So we're going to factorize the numerator. So x squared minus 25, x squared is a square number, 25 is a square number, so we have the difference of two squares. So we want to factorize this. So what we do is we open up two sets of brackets. We get the square root of x squared, which is x, and we put it in the front of each of our brackets. We get the square root of 25, which is 5, we put it in the back of each of our brackets. And we put a minus in one bracket and a plus in the other bracket. If we want to check if we're right, we can multiply out these brackets, and we'll end up back at x squared minus 25. The denominator x minus 5 cannot be factorized, we just write it down as it is. So we have factorized this expression, and we ended up with x minus 5 multiplied by x plus 5, all divided by x minus 5. Notice that we have x minus 5 in the numerator and x minus 5 in the denominator. So we can cancel those, and we're left with x plus 5. So if x is not equal to 5, we can simplify this fraction to x plus 5. So we're left with x plus 5. So the limit of f of x as x approaches 5 is the same thing as the limit of x plus 5 as x approaches 5. So we're going to swap this x for 5, so we get 5 plus 5, so we get 10. So as x gets closer and closer and closer to 5, our y gets closer and closer and closer to 10.